ohms. The inductor is equal to 120 millihenries. And my capacitance is 70 microfarads. So what we're going to do now is come up with equations for our 8 variables. The 4 currents and the 4 voltages. Now, for the current, once we get one current, we've got the rest of them, but let's do this. All right, what is epsilon sub naught? Or what is meant by RMS value? A sine curve. So I have some function y is equal to amplitude sine of omega t. Not worrying about a phase shift here. What is the average value of y for a sine curve? Yeah. So when we want to come up with an average, just doing a straight up average doesn't help a whole lot. What we need to do is we need to make everything positive. We want to know what an actual average value is. And so what they do is they square it. So we look at y squared, which would be a squared sine squared omega t. And that plot would look if that amplitude is 1, so it's not 1, it would, assuming the amplitude is 1 in my drawing, it will look kind of like that. And so now we want to average this function. So how do you find an average? Using calculus. How would you find an average without using calculus?
Add all the values and divide by the number of values.
Yeah. So what I'm going to do is I'm going to just take a small little section right here, some value of dt, and this right here would be my y value. And so what I'm going to do is I'm just going to add up an infinite number of these things. So I have a squared sine omega t sub I dt, where I equals 0 to infinity. In essence, I'm doing an integral here. So with this, oh, and then divide by the number of numbers, which would be the sum I equals 0 to infinity of dt. The calculus version of it is we're integrating from 0 to 2 pi over omega a squared sine squared omega t divided by the integral from 0 to 2 pi over omega of dt. Oops, I lost my dt here. Or in general, the average of any function is the integral of f d, whatever one you're using, from 0 to q initial to q final, and the integral from q initial to q final of dq. That's the generic average function. So all we have to do is do this little integral right here. A kind of comes out. So I got a squared integral sine squared omega t dt over, well, that one I'll do. That is going to be t from 0 to 2 pi over omega. All right, I did the second integral. What's the first integral? How would you figure out the integral of sine squared?
Look it up.
That's one way. Someone please look it up then.
Is it equal to 1 minus cosine squared?
Sine squared is 1 minus cosine squared, but then we're left with what's the integral of cosine squared.
Oh.
But there is you would have to do a substitution while they're looking it up. I know that cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So sine squared theta is equal to, that's 1 minus sine squared theta. So cosine of 2 theta equals 1 minus 2 sine squared theta. So sine squared theta is equal to 1/2 1 minus cosine of 2 theta. That's the substitution you end up doing.
The integral of, this thing says the integral of sine squared x equals 1/2 the quantity x minus
Wait, hold on. Wait. All right, so 1/2
the quantity x, or like parentheses, x minus 1/2 sine of 2x plus c, although the half applies to all of it.
So,
Yeah.
and we do have another factor to work with here because our x is omega t. And so dx would be omega dt. So we end up with basically 1/2 omega there. So we end up with running out of room. I want to keep that over there. So we had a squared over 2 pi over omega times 1/2 omega omega t minus sine squared. Was it sine squared? Or just sine?
Sine.
Omega t. I feel like I've lost something in that. Back a second here. Oh, sine 2 times that. Okay. Sine of 2 omega t. From 0 to 2 pi over omega. So we end up with my omega cancels out with that omega. So I have a squared over 4 pi times 2 pi, because pop that in for t, minus sine of, let's see, pipe that in for t, we end up with 4 pi minus the sine of 0. Sine of 4 pi.
0.
Sine of 0.
0.
So that just drops out, and what we're left with is a squared over 2. So that's the average of my function squared, but I want really the average value of this function not squared when it's all positive. And so the last thing you do is you take the square root of it, and you end up with a over the square root of 2. And that is the RMS value. It is the amplitude divided by the square root of 2 gives you the RMS. So over there, I had an RMS of 141.421. So that's my RMS voltage. And therefore, my maximum voltage is that times the square root of 2. Which is
800.
Wow, what a coincidence. This is a nice number. All right. So we now have the peak value, or amplitude, and so this right here is going to tell us omega. So if my frequency is 50 hertz, what is my angular frequency?
1 over 50.
Say it again.
1 over 50.
No. That would be my period. You could solve it that way as well, though. If your period is 1 over the frequency, so if the period is 1 over the frequency, and I know that the period is also 2 pi divided by omega, omega would be, well, 2 pi times 50. Angular frequency is 2 pi times the linear frequency. Let's get rid of some stuff here. That will be 1/4. Okay. And so the last thing is the phase shift. I know that the voltage from the power supply is equal to generically epsilon sub naught cosine of omega t plus phi. If you prefer sine, go with sine. I know that at time is equal to 0, this is half of epsilon sub naught times cosine of phi. So this is at t equal to 0 seconds. So what is phi? Or how would you solve it?
Is it 90?
Say it again.
90?
Not 90.
Inverse cosine of 2 times the power supply over epsilon.
Wait, you said the arc cosine of what again?
2 times.
Where are you getting that 2 from? From the 1/2?
I wrote down something really weird.
Okay.
I don't know.
Hey, I'll do it later on. Oh, actually, I already did. All right, so if I divide by epsilon sub naught, I get the cosine of phi is equal to 1/2. So this is the arc cosine of 1/2, which is
60.
Is it?
Yeah. Wait. I think I'm in.
1.047.
Is that what you said?
It's 60 in degree mode.
So 60 degrees.
Oh,
But
right.
we are cool because we are physicists. We want radians. Also, angular frequency is radians per second, so radians is much more convenient here. All right, so we now know that the voltage from the power supply, we have an equation now. It is 200 volts times the cosine of 3.14159 radians per second times time plus 1.047. One equation down, 7 to go. Well, we'll make short order of that because we know what the current, we can find the current easily enough. I know the maximum voltage of the power supply is equal to the current out of the power supply times my impedance. Well, we have all the information we need to find the impedance. The impedance is equal to the square root of R squared plus XL minus XC squared, or XC minus XL squared, depending upon how you're feeling. I know that XL is equal to omega times L, so that is 314.159 radians per second, times my inductance, which is 0.120 henries. What is X of L? Then X of C is 1 over omega C is 1 over 314.159 radians per second times 7 times 10 to the negative 5th farads. Units.
Ohms. Wait. Is it ohms or is that?
Say it with confidence, like that you are right regardless of what I say.
Well, I was kind of guessing, just based off memory.
Say it with confidence.
Ohms.
Does someone want to say it with confidence? All right, so if we just look at this, it would be henries per second. And a henry per second is also known as PJ.
No.
Your memory was correct. It is ohms. Also over here, in our equation here, we have voltage is equal to current times either reactance or impedance or resistance. Since the current's in amperes and the voltage is in volts, this has to be the same unit regardless. And X sub C
.473 ohms.
or seconds per farad, naturally. So therefore, my impedance for this circuit is the square root of 10 squared plus 37.699 minus 45.473, that difference squared. So we end up with an impedance of
Where did that 10 come from? Or that's the, never mind, that's the resistor.
where did the 6 come from?
Is that 10?
Oh, resistance.
Yes. .66623, not 2.
12.663 units.
Ohms.
So I now know the impedance. I know my maximum voltage is 200. That's going to be equal to my maximum current times 12.6663 ohms. And so we end up with the maximum current, the amplitude of my current phasor is so it's going to be somewhere around 8, so somewhere around 16, 16-ish.
15.7899.
15.7899 units. All right. So we now have at least the magnitude. We don't know the phase shift yet. We know what this angle here is. That's the 1.047, or 60 degrees, assuming this is time is equal to 0. We need to figure out this angle. So right now, let's see, I can get rid of this at this point. And that. I'm going to keep that up for right now. So I have the current out of the power supply, which is the current across R, which is the current across L, which is the current across C, is equal to my amplitude of 15.7899, 15.7899 amperes times the cosine of 314.59 radians per second times time.